Hi, this is Rob Sarmanian from Oakson, and in this video we're going to talk about wiring a residential size Perc-Rite Drip Dispersal System. There are several kinds of Perc-Rite Drip Dispersal Systems ranging in size from municipal, industrial, large residential. In this video we're going to talk about single-family home residential systems. Hopping right into it, you are going to provide power to a control panel. There are going to be two feeds to this control panel. Almost all the time we're dealing with 115 volts for the pump. Occasionally we need to step it up to 230, but assume it's going to be 115. So we're feeding this panel with two feeds, a 15 amp and a 20 amp. You'll be sending control wire to two different places. One will be the riser of the pump chamber, in which there are 4 floats and a pump, and the other is called a hydraulic unit. It's a series of solenoid valves along with a heater strip, and we'll show some examples of this later on in the video. But this schematic really just shows basically we're bringing power to one location and then sending feeds to two separate locations. So I'm going to ask if you remember one thing from this video. Let's pay attention to this slide. The control panel, we're going to mount it on the outside. So typically it's mounted on the house or the building itself, or perhaps on a pedestal near the tanks. This is for ease of access for maintenance or any type of service calls. Next, we talked about this, but we're going to bring two feeds into the panel. Always assume 115 volts unless otherwise specified. When bringing these feeds into the panel, we want to bring two separate hots and two separate neutrals. So we don't want to jump any of these feeds. We want to keep them separate. When dealing with splices outside of the pump chamber, we want to sleeve the riser with an 1.5 inch conduit. This is so that the SO cords for the pump and the floats can be easily removed one at a time if needed from that conduit to switch out, say, one float. If the conduit is too small, the SO cords are going to bind on each other and make it very difficult to pull one out at a time. All of the wiring in the system can be number 14 with the exception of the pump. You'll need a hot, neutral, and ground for the pump, and that needs to be number 12. When wiring the floats, we ask that you choose 4 different colors and make a pair for each float. For long-term maintenance, it makes it very easy for the operator to figure out which float is which in the control panel. For example, the off float will have 2 blue wires, the dose float will have 2 yellow wires, etc. Really easy for the operator. The heater strip and grounding lug do not have labels on them, so sometimes they get forgotten, so we don't want to forget to wire those 2 parts. Oakson is going to supply the control panel. There are 2 different models for residential systems. We'll show the differences for each. We are supplying the pump, we are supplying the floats, and that hydraulic unit with the heater strip. Here's a look at the inside of one of the model control panels. We have our breaker for the controls and the alarm, and then we have a breaker for the pump, both single pole. The neutrals are on the terminal strip, so you have P2 and 1L2 are your neutrals. P1 and 1L1 are your hots. There'll be a wiring diagram inside the box to walk you through all the other parts. The other panel comes standard with a 2-pole breaker, because sometimes this could be a 230 volt situation, but even if it's 115 volt, we're going to put the hot and neutral for the pump on that 20 amp breaker. So 1L1 is your hot, 1L2 is your neutral. The controls and alarm are fed on P1 for your hot and P2 for your neutral. And similarly, the wiring directions will be in the box for this version of the panel as well. Most of the time before you get there, the pump will already be installed in the pump chamber, but it looks like this. It'll have a nice long SO cord on it up into the riser for a connection. We will pre-assemble the floats for you, and on each of the tags it'll be marked with the corresponding terminal numbers and what the float is. So we have off, dose, peak, and high level alarm, and they'll be numbered 1 through 8. That corresponds to the wiring diagram. Here are the hydraulic units. These are the two different styles. One of them comes with a long whip and the other has a shorter whip. The shorter one only has 3 conductors and the larger has 5 conductors. So the 5 conductor hydraulic unit looks like this. Each of the conductors are tagged, 24 being the common, and all the other solenoids are marked on the wire. These go to terminals 11 through 15. And don't forget your grounding lug tucked down there on the bottom. This 3 conductor hydraulic unit has a shorter whip. 24 is still the common, and then your 2 solenoids that go to terminals 11 through 13. And there's the grounding lug, a little more prominent than the other model, but still sometimes overlooked. The heater strip will sit right on the aluminum skid plate. There's no polarity, so there's no tags on it. These get wired to terminal strip 9 and 10, and they're on either version of the hydraulic unit. As previously mentioned, you can use number 14 wire for the majority of the system. The only thing that needs to be number 12 is the pump itself, which would be a hot, neutral, and ground. Everything else can be 14. Use a lot of colors when possible. We like to choose a pair for each float being the same color, and the different solenoids can be a different color for each of the wires. So the next section, we're going to go through different types of conduit layouts from the control panel to the pump chamber and the hydraulic unit. So here is the control panel mounted on the outside of the home. You have an LB coming into the bottom with your feeds, and from there you can kind of see the terminal strip with the different color wires going out a single conduit that's going to be landed in between the pump chamber and the hydraulic unit. Here is an example of an electrician who used 2 conduits to go from the control panel out to the hydraulic unit and the pump chamber. We see one of the conduits is going into a PVC box. You have the SO cords for the floats and the pump in that box, everything tagged, and then the other conduit is going directly into the enclosure of the hydraulic unit. Here is a similar example. With 2 conduits, you have a sleeve coming from the pump chamber into the PVC box. They used 1.25" pipe, which is acceptable, but a little bit on the smaller size. 1.5" makes it a lot easier to pull one of those SO cords back if a pump or float wire needs to be swapped out. Here is an example of an exterior junction box that comes pre-made into this corrugated riser. So you have one pipe going into that junction box and the other going straight up into the underneath of the enclosure of the hydraulic unit. Here's another view of that. Another very common and acceptable way to bring the wiring from the control panel to the hydraulic unit and pump chamber is a single conduit to an open air splice. You see the one pipe landed in between the pump chamber and the hydraulic unit. We have a sleeve going from the pump chamber, and we have another from the hydraulic unit. All of this wiring will be spliced together and have that handhole mounted over the top and be accessible at grade. No PVC box was used, but silicone wire nuts are used and are very acceptable for this application. Here is another single conduit example. This time the electrician chose a PVC box with a sleeve going into the riser and another piece of flexible conduit going into the hydraulic unit. Here's a bird's eye view of inside the pump chamber. you can see the 1.5" sleeve with the pump cords and flow cord leaving to go into whichever splice box the electrician chose for this application. Here we are back at the example of the built-in splice box. In this application, there are SO connectors to which the pump and flow cords get attached to, and all the wiring splices are done outside in that attached splice box. Here are the pump and flow cords attached to those SO connectors and the splices being made. Some applications call for the control panel to be mounted on a pedestal. If the pedestal is mounted close enough to the hydraulic unit and the pump chamber, you can direct pull the whip for the hydraulic unit and the pump and flow cords directly into the control panel, eliminating the need for any splices outside. Here is another example of a pedestal mounted control panel with no exterior splice boxes. Here is a 3-conductor short whip hydraulic unit. What's great about this picture is you see that the electrician used silicone wire nuts for all the connections, pulled a few spare, and used duct seal for the pipe. So in review, let's talk about some of the key points for you to be prepared for a Perc-Rite installation. The control panel is going to be mounted on the exterior. So if you know that there are challenges to get feeds from inside the house to wherever the control panel is going to be mounted, you can prepare for that ahead of Oakson's arrival to the installation. We see the control panel mounted typically on the building or sometimes on a pedestal. These residential panels have 2 feeds. One of the feeds is for the pump and the other takes care of the alarm and the controls. For each of these feeds, we want separate neutrals, so no jumpers. When splicing outside of the pump chamber, we prefer you use an 1.5" sleeve. That way the SO cords can be individually pulled out of the splice box for any type of service or swap out. When choosing your wiring, you can use number 14 for the solenoids, the heater strip, and the floats. We only need number 12 for the pump since it has 20 amp protection. When wiring the floats, please try to use 4 different pair of a color for each corresponding float. And lastly, the heater strip and grounding lug are not apparent sometimes. They get buried on the bottom of the skid plate, so don't forget to wire those. We are here to help you, so if you have any questions prior to the installation, don't hesitate to pick up the phone and give us a call. Thanks for watching the video. I hope you're better prepared for your installation, but if not, please give us a call at 978-282-1322. Looking forward to seeing you on site. Thanks.